Thank you. First of all, I want to make sure everyone gets their money's worth, so I actually have 6 stories, not 5. So one's kind of a bonus at the end, so I want to make sure you get the best use of your time. The goal of this talk is really going to be to help understand how we collaborate with different organizations and really see the different angles in which we do so. Each one is hopefully from a different angle to help see kind of the different ways in which we approach and add value to collaborations. First, a word on our company. Quantinuum just celebrated its 1-year anniversary last week. So even though we're a relatively new name, we come from 2 longtime players in the field, Cambridge Quantum on the software side and Honeywell Quantum Solutions on the hardware side. We are a global presence. We have offices in the United States, throughout Europe, in Japan, and we're constantly expanding and looking to grow. We have about 500 employees, more than 500 now, and about more than half of those are scientists and engineers. So we're an incredibly science-led company. Now, to give a little bit of some background on our integrated approach, which is really how we approach solving problems, at the end of the day, we want to solve industry problems across all different verticals. So the most pressing computational bottlenecks and challenges, that's what we're trying to address. We have a variety of different application areas. One is cybersecurity, where we actually have a product, Quantum Origin, which produces the best cryptographic keys in the world. We also have a package for quantum chemistry called Enquanto, which allows us to do chemical simulation on quantum computers. And then finally, we have a whole bunch of other areas where we do R&D collaborations and work on projects ranging from optimization to Monte Carlo simulation to natural language processing and machine learning. And all of our applications are built on top of our software development kit, which is open source, called Ticket. Ticket allows us to maximally run our applications in the most resource efficient way. And it also is back-end agnostic, so we were able to run it on any gate-based quantum simulator or hardware that's out there, including our own H-series, which we're developing in-house. So it's a very powerful tool to run multiple applications and deploy them most efficiently. Now, to give some examples of how we collaborate, we usually follow this 5-step process. First, we do use case identification. We really find where are the best use cases that can add value to a business and help to rank them and really see which ones could we attack with a quantum computer. Next, we create a suitable model where we actually take a given problem and map it into some sort of mathematical formulation that can be run on a quantum computer. Sometimes that's easy, sometimes that's very, very hard, and that's a lot of value that we bring through the collaboration. We then work on developing a new algorithm or workflow. This can show up in a lot of different ways, but this is really the meat of the collaboration, where we're developing something brand new, some new kind of technology to assess a particular problem. We then test this on actual hardware, sometimes multiple hardwares, to actually compare and see how it runs, what kind of errors does it have, what kind of times, things like that. And we finally will assess our capabilities in usually a publishable report that summarizes everything we've done and lays out opportunities for future research and things like that. Finally, everything is done aimed at being able to trivially scale up. So as the hardware improves, we can use our same algorithms and workflows and grow alongside the hardware. So for the first story that I want to talk about, one more thing. We also flank all of our collaborations with training and workshops to really make sure we're conveying our knowledge to our collaborators and that we can really work with their domain expertise and our quantum expertise together and really transfer that knowledge well. So the first story I want to talk about is really focused on a problem that is out there in industry and then how we found a solution to that problem. And this involves work with Nippon Steel. Now, they're a major steel corporation that has to run through, they have to take raw resources and go through manufacturing processes that often have bottlenecks and are very complicated. So we helped them develop a formulation for their particular optimization problems that can map onto a quantum computer to do their manufacturing optimization. You can read about it more in this link we have published here. And not only did we create this formulation of their problem, but we were also able to develop a brand new tool to solve optimization problems like this, a new algorithm called FVQE. We tested FVQE on multiple problem sizes, and it showed great performance as the size increased. But what's most exciting about this work is it's an example of finding a particular problem, building a solution to that problem, and then letting this solution transfer to other areas in industry. And we've actually applied it into work that we've done with route scheduling optimization, as well as optimization problems in the oil and gas sectors. So it's a really cool example of taking a specific problem and a solution that's general. The next story I want to talk about kind of flips this around. And it really is the idea of building a solution and then seeking a problem for it. And this is work that we've done with Crown Bio that's currently ongoing. But I first want to take a step back and talk about the solution we built. Our quantum machine learning team, along with our other research teams, are constantly innovating. And they're working on developing new techniques and tools even when we don't know exactly where they will apply. And this is an example where our teams developed new algorithms for variational inference, again, referenced here if you want to read the paper on those particular algorithms. And variational inference helps us answer questions like this. When we have cases where we have observed variables, denoted in the green, for example, here, and we want to say something about variables we can't observe. So maybe in the case of disease prediction, we can see symptoms and observe them, but we can't. But we'd like to say something about what are the underlying diseases or the conditions of that particular patient. This can also show up in cases like financial time series, where we might look at observables like stock returns and want to say something about the unobserved market condition. So that's kind of where variational inference fits. Well, after developing these algorithms, we were able to find a great use case that we're currently working on with Crown Bio to help develop new multi-gene biomarkers. If you're not familiar, a biomarker is something that you measure in the human body, and it can help you predict how will you respond to a drug, or are you high risk for a certain disease, things like that. Looking at multiple combinations of genes for biomarkers is a really hard computational problem. It's a combinatorially scaling problem, so it's very well suited for our variational inference techniques. So we're really excited to have an example where we built a new tool and then found a place where we can apply it in industry and add value. The next story I want to talk about is a little bit of a different focus, and really focusing on how we can help upskill subject matter experts with our quantum expertise. And this involves work that we're doing with Equinor. Now, Equinor is an incredibly innovative energy company. They're looking at solar sources of solar energy, wind energy, carbon capture, hydrogen fuel cell technology. And one of the big problems with that is that one of their biggest barriers is that requires the constant development of new catalysts and materials. And that's very hard. I come from a chemical background, and I know that is not done overnight. So they're exploring the possibility of quantum computing to help maybe be a tool to start attacking these kinds of problems. And in particular, they're using our product in Quanto as a tool to start exploring computational chemistry on quantum computers. And Equinor has an in-house quantum team that they've built, and it consists of their brilliant mathematicians and physicists, and they're really looking to work with us and allow our expertise in quantum computing to be conveyed into them throughout the duration of this collaboration. We're conveying our expertise through a few concrete methods. One is through use case workshops. We're working with them to help find use cases across their business, identify and rank which ones are best suited for quantum computing. We're also looking at quantum chemistry trainings where we're conveying our expertise of how to do quantum chemistry on quantum computers, as well as in Quanto demonstrations where we can demonstrate how to use our package best for particular applications that they're interested in and things like that. And then finally, joint algorithm development, where we're working to develop algorithms and workflows together and lend our expertise to that. So it's a really good example of how a company who wants to explore quantum computing can really benefit from working side by side with our experts, and we can convey our knowledge to their team so they can assess quantum computing and how it fits for their business needs better on their own. A somewhat related story that I want to share is our work with Honeywell. And Honeywell, as you know, is a massive conglomeration of many different and diverse business units. So when you take a company like Honeywell and they have a division like Performance Materials and then other areas like Aerospace, those are very, very different businesses. They have different problems, they have different scientific and computational challenges. So it's really hard for Honeywell to find a one-size-fits-all quantum strategy for how to approach quantum computing. So by working with us, we can help them shape a holistic quantum strategy. Honeywell is an early hardware subscriber, and they have access to our H1 series hardware. And we've been working with their subject matter experts across a variety of different business units to really help them identify where are the best positions in the business where quantum computing can fit. There are some cases where we say, hey, this is a problem that quantum computing is not best suited for, but we've been able to find others where there's really good synergies and quantum computing could be a very valuable tool for particular challenges. So we have many ongoing conversations with Honeywell subject matter experts across the different business units and can really help, identify where are the best places for quantum computing to fit. One case that we found and work that we've been doing so far is to look at simulating reactions relevant for the production of refrigerants, which is a core business unit of Honeywell. And we've been applying our Enquanto package to simulate these reactions and potentially study new pathways and ways to approach the creation of refrigerants. So this is a good story and a good application for businesses that are very large and they have lots of diverse challenges and problems of how we can really help to shape where the quantum focus should be. The fifth story that I want to talk about is how we integrate our existing solutions and products with other solutions and products to bring an even better experience to end users. And this involves our cybersecurity work with a company called Frenetics. And before I talk about how we're working with them, I'd like to take a step back and just have a brief mention of cybersecurity. In any cybersecurity stack, the very foundational layer is the cryptographic keys. If one has compromised cryptographic keys, everything else falls apart. It doesn't matter what you do up here, if these are broken or they can be hacked. And there's really three aspects we can talk about when we look at cryptographic keys. The first is key algorithms, the second is key generation, and the third is key management. Now, key generation is what we do really, really well. Our platform, Quantum Origin, allows us to use quantum computing, quantum processes, and our quantum computer to both generate and verify the strongest cryptography keys in the world. That's really valuable in its own right, but I'll talk about how we're able to integrate that and make it even better. On the key algorithms front, this is really where organizations like NIST are setting the standards for what are the next post-quantum algorithms going to be. And then key management is where a company like Frenetics steps in. Frenetics they have a key management system called Vault Core. So we're working with them to integrate our Quantum Origin solution with their Vault Core solution, which allows us to more easily deploy and manage keys that are produced from our quantum processes. This is really exciting, and we're currently working on use cases related to secure communications, but we expect that this could be a solution that can extend to a variety of different, more general cybersecurity use cases. And it's just an example of how we're looking for ways to make Quantum Origin more easily deployed and to help make a better experience for end users who are looking to secure data and communications. All right, the last story I want to tell is a bit of a bonus. And for the audience, I have a quick question. So who out here has found mathematics to be a barrier to understanding some part of quantum or quantum computing ever in their career? I hope I see almost every hand go up. I'd raise 3 hands if I had them. Quantum mechanics is incredibly difficult from a mathematics point of view. And one thing that's unique about Quantinuum is that we're really committed to developing the entire ecosystem. And on one front, that means how can we make quantum more accessible to everyone? One way that we're approaching that is through this new book that our chief scientist, Bob Kuka, has just released. This will actually be released on Amazon in the next couple weeks. So this is something that everyone can purchase. And what Bob has done has really taken these complicated mathematical formalisms for quantum mechanics and found ways to represent that in simple diagrams and pictures. So it's almost an entirely different language to think about quantum mechanics that's maybe more intuitive and easier to access without the need for high levels of mathematical training. Now, we're really excited about this book, and we're going to be giving away 5 copies. So if you're interested, please come stop by our booth and put your name. We're going to have a raffle for it, and we'll eventually give these books out once we have hard copies of them. We have a book that you can look at our booth as well to see if you want to skim through it and see what's inside. But we're really excited about this. And not only are we excited about the book, but we want to prove that the approach really has some merit. And we're going to do that through a sort of competition. We're working, this is ongoing and it's not completed yet, so it's kind of a teaser. But we're working on training a group of high school students using this picturing quantum, this quantum in pictures formalism. And we're going to have them compete on the same exam with Oxford University students who approach it using the same traditional mathematical formalism. And we're really hoping that we can demonstrate that this makes quantum either accessible and that these students can either beat or at least be competitive with the university students. I'm really excited to see the results. I hope everyone in here is rooting for the high schoolers because this is good for the entire field. If we can take something that's really, really complex and make it more accessible and obtainable for everyone, this really can help develop the quantum ecosystem as a whole. And this is ongoing work with a variety of collaborators, some from Quantinuum and Oxford as well. So it's really exciting, and keep your ear open for future results. So in summary, I hope you've seen that I have I've shown a variety of diverse areas that we've collaborated at Quantinuum with a lot of different types of companies and industries. And I want to give 2 invitations. One, this is only a small selection of the stories I could tell. If you want to hear more, please come talk to myself or any of my Quantinuum colleagues, and we can give you many more stories of the exciting work that is going on. But the second invitation is that this is really only the first chapter that we're writing here. And we are going to be writing chapter 2 and 3 with more different use cases, different types of collaborations. So if anything I've talked about has resonated with you and your business and sounds like you'd be interested in more conversations of how you could write chapter 2 and 3 along with us, we'd be really excited to have more conversation on that. Thank you all for listening, and I'd also like to note that our president and COO, Tony Utley, will be giving a keynote tomorrow morning at 9:40. So I'd encourage everyone to make it to that. He's a fantastic speaker, and we're really excited to share what he has to say. Thank you, everyone.
Not just yet, Mark. You have to stay on the stage real quick. So we do have 30 seconds left. And since Mark was innovative enough to ask the audience a question, we owe it that at least one short, brief question from the audience. Yes.
Hey, Mark.
Yep.
Hey, Mark. Carl Leopold, Infineon. Thank you very much. So we do work on post-quantum cryptography. Mm-hmm. The natural question begged is, have you done anything to try and crack quantum cryptography? Or excuse me, crack cryptography using quantum computing?
Our focus right now is really the positive side of how can we reinforce cybersecurity today, and that's what Quantum Origin focuses on. So that's really our main focus, but I will say in terms of post-quantum, Quantum Origin can produce keys that are suited for those post-quantum algorithms. So it's something that we're thinking about. We're highly active and engaged in all of those discussions, but we're really focused on the defensive, positive value that we can add today.